Hi, this will be a video about factorizing quadratic expressions using the cross method. Before we can factorize using the cross method, we need to get our quadratic expression in the general quadratic form. Or in other words, ax squared plus bx plus c equals 0. Afterwards, we draw a cross underneath. Now on the left-hand side, we have a pair of factors m and n that can multiply each other to get a, the coefficient of x squared. Afterwards, in a similar fashion, we would get a pair of factors for c. So these two factors would multiply together to get c. And this is where we use the cross. So the cross would tell us to multiply m and q together. And once we do that, we can write mq at the bottom. And the cross would also tell us to find the product of n and p by going diagonally upwards. So we got to add that to mq. And the sum of these two products will have to equal to b, our coefficient of our middle term, x. So once all of these three conditions are satisfied, we can simply write our factorized expression in the form of mx plus p all times nx plus q. Now all of this seems a little bit confusing and a bit of mumble jumble at first without any numbers inserted. So let's try out an example to demonstrate all of this. Okay, so let's start with an easy example where a is equal to 1. So here we have x squared plus 5x plus 6. So I'd just like to repeat that a is equal to 1 in this case, since it's implied that our coefficient here in front of x squared is 1. So just like the previous slide, we draw a cross first. And on the left side, we get a pair of factors for our a value, 1. So there's only one possibility here. So we have 1 times 1. Okay, so on the right, we start listing our pair of factors for 6, which is our c value. So we have 6 and 1, and we also have 3 and 2. So note that you can also have a pair of negative factors, but in this case, all our coefficients in our general quadratic expression are positive, so we don't need to consider those. Okay, so now we need the sum of these products to equal to 5. So let's experiment a little bit with cross multiplying. So first of all, we go downwards. We have 1 times 1, 1. Go upwards, 1 times 6, we have 6. Add these together, we get 7. And that's not quite what we want. We want 5. So let's try again. Okay, so now we have 1 times 3 going upwards. And we also have 1 times 2 going downwards. So we have 2 plus 3. And this is equal to 5. Perfect. Okay. So now we can just write our factorized expression by looking at the chosen values in rows. So in the first row, we have 1 and 3. So our first factor is 1x plus 3, or just x plus 3. So let's try a harder example this time. A is still equal to 1, but we have negative coefficients this time. So here we have x squared minus 7x minus 18. Okay, so we draw the cross again. Our left pair of factors would just be 1 and 1 again, because a is still equal to 1. So now we need factors of c, negative 18. So our first pair can be negative 9 and 2. 9 and negative 2 must also be considered. So we have negative 18 and 1, and 18 and negative 1. Alright, so now we need to experiment a little bit with the cross multiplying to get our sum of products equal to negative 7, which is b. So we go downwards and we get 1 times 2, 2. Then 1 times negative 9 and we get 2 minus 9. This is equal to negative 7. Oh, so we got it first shot. Awesome. So now we have our factorized expression by just reading the rows again. So in our first row we have x minus 9, and the second row would say we have x plus 2. So this would be our factorized expression. Okay, in this last example, we'll have a equal to another number. So let's say our expression is 2x squared minus 13x plus 20. So just like factorizing using cross method like before, use the cross. On the left side this time we have a pair of factors for 2. So we have 2 and 1. Now you notice that we're rearranging the order of these factors on the right hand side before, but we'll make it a rule that we don't need to rearrange the pairs of factors on the left, because rearranging the factors on both sides of the cross will be inefficient. Just rearranging the factors on one side will net you all of the combinations from cross multiplying. So note the negative 13 coefficient for x here. So we should be considering pairs of factors that are where both numbers are negative for positive 20, which is our C value. So here we have it. These are all our factors for positive 20, where both numbers are negative as well. And I also rearranged the order of the factors to consider all possibilities for cross multiplying. So negative 20, negative 1, negative 10, negative 2, and negative 4, negative 5. So let's begin experimenting to get our sum of products to be negative 13, which is our B value. Okay, going downwards we have negative 2. Going up the cross we have negative 20. Adds up to negative 22. That's a no-go. So we'll try the next column. We have 2 times negative 20, negative 40. It's way off. We have negative 41. So the next column we have negative 4. And going up we have negative 10. Close but no cigar. So we'll go down the cross again. Negative 20 minus 2. Negative 22 again. That's not good. So in the next column we have negative 10 minus 4. Negative 14 again. Alright, so this is our last resort. We're going to try going down the cross, negative 8. Going up the cross we have negative 5. Negative 8 minus 5, that's negative 13. Perfect. So again, we can just factorize our expression just by reading across the rows. So in the top row, we will have 2x minus 5, and the bottom row states our other factor is x minus 4. And you can prove that this is correct by just expanding your factorized expression to get your expression from the beginning. So that was the last example, and this concludes the video on factorizing quadratic expressions using the cross method.